nice logs, what is going on, structured log levels, and in the end also structured logging for arbitrary key value metadata. What you will see is standard out and standard error is actually captured. So this allows us to have a single pane of glass here for the logs, even for remote execution engines like in Databricks or EMR. It makes it rather convenient to debug. Let's jump into the code. So basically we have a script. You will see we have an execute business logic function that is receiving the engine in various config parameters. And that basically is just in this body of the function doing whatever you want it to do. So for example, you can read some data set, do something with Spark, and then have a data frame and count some data. The interesting stuff is, because we have the support of Dagster here, we can perform structured logging. So for example, we can report the asset materialization here. And if I show you also the second one, you will see that similar steps are performed here. Let's move over to the whole metadata that is needed. Basically, now having these scripts external to Dagster, we can now basically configure Dagster, make him aware of it, and add also various parameters that are required for the remote execution environments. So we have a script, the scaling parameters. In fact, these may be different for the separate like Databricks and EMR config settings. And we can also add specific libraries here that are required for the Bootstrap. So they are installed on top or in addition to whatever the Databricks or EMR environment is providing out of the box. On the Dagster side, we basically have a little bit of metadata, basically string it all up, but that's nothing fancy. Where it gets interesting is the resources config. As you can see, we have a dev and a prod resource, and we can basically swap execution engine here per environment. In fact, our factory that we have seen before here allows even to override on a per asset basis to some other engine if you want to.